Hello, welcome to part 2 of our tutorials on the solutions to Further Mathematics paper 1 of June 2023. In part 1, we tackled questions 1 to 25. So in this second part, we are going to tackle questions 26 to 50. And for those who did not watch the first part, you can look at the video description below this video and you would see the link to that part so that you can also watch. Okay, in number 26, we have given that A and B are two vectors, which one of the following compound statements is true? Now let's start by considering this formula. A dot B equals A magnitude B magnitude cos theta. Whenever A is perpendicular to B, the angle between them should be 90 degrees, and the cosine of 90 degrees is 0. It implies that A dot B will always be 0 so long as A is perpendicular to B. So option A is true. Now in B, A dot B equals 0 if A is parallel to B. That is not true, because if A is parallel to B, it's either the angle between them is 0 if A and B are in the same sense, or the angle between them will be 180 if they have opposite sense. The cosine of 0 is 1 and the cosine of 180 is negative 1. So there is no way A dot B can be 0 if the two vectors are parallel. Now in C, A cross B equals C cross D follows that A equals C and B equals D. This statement would not always be true, and in fact there are counter examples that we can use to disprove that statement. Now in the D part, A cross B is parallel to A if A is perpendicular to B. In the case of A cross B, the magnitude should be equal to A magnitude B magnitude sine theta, and if A is perpendicular to B, it means that the angle between them again will be 90 degrees, and sine 90 is 1, so that A cross B magnitude would just be equal to the product of A magnitude and B magnitude. And this statement does not give us any clue about A cross B being parallel to A, so this other statement too is not correct. In number 27, for what value of P is the matrix 433 P56679 non-invertible? And we have these options. For a matrix to be non-invertible, it is about its determinant being 0, because if the determinant is 0, the matrix has no inverse, so it is said to be non-invertible. So we're going to find the determinant of this matrix and equate it to 0 so that we can get the value of P. Determinant should be 4 times the minor of 4, which should be 5, 6, 7, 9 minus 3 into the minor of 3. It should be P669 plus 3 into the minor of 3, which should be P567. All that should be equal to 0 since the matrix is non-invertible or a singular matrix. So we have 4 into the determinant 45 minus 42, which is 3, minus 3 into 9P minus 36 plus 3 into 7P minus 30 equals 0. 4 times 3 will be 12 minus 27P. Negative 3 times negative 36 will be plus 108. Plus 3 times 7P would be plus 21P. 3 times negative 30 would be negative 90 equal 0. And negative 27P plus 21P would be negative 6P. And that will be equal to 12 plus 108 should give 120. 120 minus 90 will give 30. Sending 30 to the right hand side will be negative 30, and we have that P equals 5 when we divide both sides by negative 6, and that corresponds to option A. In the next question, question 28, we have a necessary and sufficient condition to show that a group is not abelian is, and in this case we have D as the correct option, because for a group to be an abelian group, it suffices that the commutative property should be obeyed by the binary operation that together with the set forms the group. In number 29, the solution of the system of congruences x is congruent to 1 mod 2, x is congruent to 2 mod 3 is, and we have these options. Now if you look at the two congruences, you would see that mod 2 and 3 are pairwise relatively prime, and we could use the Chinese remainder theorem or the algebraic method to solve the problem. But since this is MCQ, it is easier instead to investigate the various options in order to get the correct answer. Actually, the congruences can be interpreted like this. we have x congruent to 1 mod 2, which actually means the natural number x, such that when it is divided by 2, the remainder is 1, and the same x when it is divided by 3, the remainder is 2. So if I start with the biggest of the options that I have here, x equals 5. If x is 5, we can investigate in the first congruence there. 5 divided by 2 would always give you a remainder of 1, and 5 divided by 3 would always give you a remainder of 2. So the correct option is G. If you investigate 4, 3, and 2, you would see that they don't satisfy that set of congruences. But if we want to go by the algebraic method, then we'll take the first congruence and express it in the division algorithm form, so that x should be equal to 1 plus 2 times k, where k is the quotient, usually an integer, so that we substitute it in the second congruence. So 1 plus 2k should be congruent to 2 mod 3, and then we make k the subject, so that we get 2k congruent to 1 mod 3. And in order to make k the subject, I will have that 2k is congruent to 4. If I add 3 to 1, the modulo I add it to 1, I will have another number congruent to 1 in mod 3. And 4 being a multiple of 2, I can now be able to cancel 2 on both sides, so that k should be congruent to 2 mod 3. I'll write again that k in the division algorithm form as k equals 2 plus 3 times alpha, another integer, and I will take that k now and substitute in this first equation, so that I have x equals 1 plus 2 into k, and k now is 2 plus 3 alpha. So I get 1 plus 4 plus 6 alpha, so that x now will be equal to 5 plus 6 alpha. So x is congruent to 5 in mod 6, so that 5 becomes the smallest natural number that can satisfy the two congruences, and again it corresponds to D as the correct option. In the next question, we have the solutions of z cubed equals -8 as z equals, and we have these options. Actually, to solve this problem, we can do it algebraically, or we apply the Morse theorem. If I want to do it algebraically, I will have z cubed plus 8 equals 0, so that z cubed plus 2 cubed, because 8 is 2 cubed, equals 0. And then we can apply the identity for sum of two cubes. A cubed plus b cubed equals a plus b into a squared minus ab plus b squared. So we have this identity. Applying it to the left hand side of our equation, we would have z plus 2 into z squared minus 2z plus 2 squared, which is 4, equals 0. So that we have either z plus 2 equals 0, following that z equals -2, or z squared minus 2z plus 4 equals 0, following that if we apply the quadratic formula, we would have that z equals negative of -2 plus or minus the root of -2 squared, which is 4, minus 4 into 1 into 4, all that over 2 into 1, and that gives us 2 plus or minus the root of 4 minus 16, which is -12, all over 2. And the appearance of -2 in the square root there indicates that we have complex roots in this case, so we replace negative by I squared. So this gives us 2 plus or minus the square root of 12 is 2 root 3, and the square root of I squared, which is replacing the negative there, would just be I, and we are dividing by 2. So at the end, the z should be, when you distribute the denominator, which is 2, you have 1 plus or minus root 3i as the other two roots. So finally, z should be equal to -2, 1 plus or minus root 3i, and that corresponds to option A. In the next question, we have the general solution to the differential equation 4d squared y over dx squared minus 3 dy dx equals 0 for constants a, b is y equals, and we have these options. So this is a homogeneous second order differential equation. So we start with the auxiliary equation, which is 4m squared minus 3m equals 0, so that m can be factorized to have 4m minus 3 equals 0, and we have that m equals 0 or m equals 3 all over 4. So the general solution should be y equals a e to the power, the first root of the auxiliary equation, which is 0, into x, plus b e to the power, the second root, which is 3 over 4, and then x. and this gives us e to the 0 is 1, so we have the first term there as a, plus b e to the 3/4x, and that corresponds to option B. In the next question, we have integral of 1 all over the root of 9 plus x squared dx, where k is a constant is, and we have these options. Actually, in integrals where you have 1 all over the square root of either the sum or difference of two squares, you would have to use standard formula. So this formula, integral of 1 all over the root of a squared plus x squared dx, corresponds to sin inverse of x over a. This is very common in Further Mathematics paper 1. When you see sum of two squares at the denominator inside the radical sign, know that the integral will involve sin inverse of x all over the root of the constant term inside the radical sign. So here we are dealing with integral of 1 all over the root of 9 there is 3 squared plus x squared dx, which should then be sin inverse of x all over the square root of 3 squared there, which is simply 3, plus c, and that corresponds to option C. Now, if instead I had a negative sign inside, it would be 1 all over a squared minus x squared, and it will correspond to sin inverse. If it is instead x squared minus a squared, it would correspond to cos inverse. In the next question, which is question 33, the equation x squared all over 2 minus a plus y squared all over a minus 5 equals -1 represents an hyperbola if, and we have these options. So to solve this question, we actually start with the standard form of the equation of a hyperbola, which is supposed to be x squared all over a squared minus y squared all over b squared equals 1. And when you compare it with what is given, you see that we need to modify. So the right hand side is not 1, but instead -1. So we start by multiplying the equation through by -1, so that we get -x squared all over 2 minus a, then minus y squared all over a minus 5 equals 1 when you multiply all through by -1. And now 1 is okay, y squared over a minus 5 is okay. There is a negative sign already between the terms, but the negative that is in front of x squared there has to disappear, so I would bring it down to the denominator so that I can modify it, and the equation now becomes x squared all over a minus 2 minus y squared all over a minus 5 equals 1. Now, actually, to solve this problem, we have to look at the denominators of the standard equation. They are all squares, so there is a squared and there is b squared at the denominators of x squared and y squared respectively. So being all squares, it means that a minus 2 must also be a square, and so it should be greater than 0, as well as a minus 5 must be a square, and so it should also be greater than 0. So here we have that a should then be greater than 2 and a should be greater than 5 in this other case. So looking at the two inequalities, we would see that there is 2 and 5 as the critical values, and a being greater than 2, it means it has to be in that region, satisfying it, whereas a greater than 5 has to be in this other region, and the two regions actually intersect where a is greater than 5, and so a greater than 5 is the correct option, which corresponds to D. In the next question, question 34, given that m equals 1 2 3 3 2 1 and n equals 1 2 3 2 3 1 are elements of S3, the symmetric group of permutations of A equals 1 2 3, the composition mn equals, and we have these options. Actually, to do the composition of a function like this, we have to perform n followed by m. So we do the composition from left to right, and so I would start from n and then n with m. So in n, I would have to map 1 to 2 and then go to m and map 2 to 2. So we end up having that composition maps 1 to 2, and then 2 is mapped to 2 by m, and so the image of 1 is 2. In the options, it is only in B where we have the image of 1 being 2. Let us confirm whether the image of 2 is 1 and the image of 3 is 3 under the composition. So we take 2 maps to 3, and 3 maps to 1, and that corresponds to the fact that the image of 2 is 1 under that composition. We take the case of 3 maps to 1 and then 1 maps to 3, so the image of 3 is 3 under the composition, and that corresponds to what we have. So actually B is the correct option. In number 35, if the rate at which cells in a certain organism die is inversely proportional to the number n of cells present at time t, treat n as a continuous variable with k a positive constant. Then which one of the differential equations is satisfied by n? Actually, this is a rate problem, and each time you are reading a rate problem, look out for the word that signifies either increase or decrease. In this case, we have organisms dying. If they are dying, it means the number present at any time t would be reducing, and so we have the case of a decrease rate. In that case, we can now say that dn dt is proportional. Since they have said inversely proportional, it should be proportional to 1 all over n, so that we get dn dt equals negative k all over n, where the negative sign indicates the decrease in the number of cells. So this corresponds to option A. In question 36, we have that using the approximation yn plus 1 is approximately yn plus 2h dy dxn and a step length of 0.1, the approximate value of y when x is 1.1, given that dy dx equals x plus y and y equals 0 when x equals 1 is, and we have these options. So we have been given the approximation, and the step length, which is supposed to be h, is 0.1, the approximate value of y when x is 1.1, given that dy dx, so this is dy dxn, which should be equal to xn plus yn, and y equals 0 is the initial value of y, so it is y naught, whereas x equals 1 is the initial value of x, which is x naught. Now x1 is supposed to be a step ahead of x naught, and so x1 should be x naught plus h, that should be 1 plus 0.1, which gives 1.1. So actually we are looking for the value of y when x is 1.1, and since this corresponds to x1, it means we are looking for y1, which should be the solution to this problem. Now to have y1, I will substitute n equals 0 in the approximation there, so I have yn plus 1 is approximately equal to yn plus 2h and then dy dxn, which is now replaced by xn plus yn, so into xn plus yn. Now when n is 0, I have y1 to be approximately equal to y0 plus 2h into x0 plus y0, and y0 is given as 0 plus 2 into h is 0.1 into x0, which is 1, plus y0, which is 0. All this gives us 0.2 into 1, which is approximately 0.2, and that corresponds to option D. In number 37, we have a particle performing simple harmonic motion has a speed of v meter per second when it is 1 meter from the center of oscillations. If the period of oscillations is √2 pi seconds and the amplitude 3 meters, then the value of v in meter per second is, and we have these options. So in questions asking for v when the amplitude, the distance from the center of oscillations, and mostly the period has been asked, we use v squared equals omega squared into a squared minus x squared, where v is the linear speed, omega is the angular speed, a is the amplitude of oscillations, and x is the distance of the particle from the center of oscillations. Then we need to calculate omega because we have been given the period, so omega should be 2 pi over the period, which is 2 pi all over √2 pi, and that gives 2 all over √2. Multiplying up and down by √2, we'll just have √2 rad per second as the angular speed. So substituting the formula, then we have v squared equals √2 all squared into the amplitude squared, and the amplitude is 3, so 3 squared is 9 minus x squared, and x is 1 because the particle is 1 meter from the center of oscillations, so 1 squared, which gives 1. So v squared equals 2 into 8, which gives 16, so that v should be the square root of 16, 4 meter per second, and that corresponds to option D. In the next question, which is 38, we have the moment of inertia of a uniform rod of mass m and length 3l about an axis through its center and perpendicular to the rod is, and we have these options. In the case of the moment of inertia of a rod about an axis through the center, the formula booklet provides you with this formula: 1/3 ml squared. you have to note here especially that this formula is for the case where the rod is of mass m and the length is 2L. So when the mass is m and the length is 2L, the moment of inertia about the center is 1/3 ml squared. So if you go to the formula booklet, it can be very erroneous if you don't interpret it well. For a rod, the moment of inertia about the center is 1/3 into, you write the formula in words instead, so into the mass times half the length, so length all over 2 all squared. This is the best form of the formula to use anytime you come across questions, especially in multiple choice. Even in paper 3 further maths, use this form, the one that is written in words, because most of the time the mass may not be given as m, it will be given as a multiple of m. You could have 3m, 2m given, and it will become erroneous, or you can misinterpret and you get the wrong formula and calculate wrongly. So in this case, then we have 1/3 into the mass here is m, into the length, and the length is given as 3L. We divide it by 2 and then we square. That would give us 1/3m into 3/2L squared gives 9L squared all over 4. And finally, when we simplify 3, we cancel 9 to give 3. You have 3 all over 4 ml squared as the moment of inertia for the rod. That corresponds to option C. In question 39, we have a force F equals 2I minus j plus k newtons acts on a particle, giving it a displacement of I plus j plus 2k meters. The work done by the force is, and we have these options. So actually, work done by a force vector is related to the dot product of the force vector and the displacement vector r. So this simply has to do with 2, -1, 1 dot the displacement vector, which is 1, 1, 2, and that gives you 2 into 1 plus -1 into 1 plus 1 into 2. All that gives 2 minus 1 plus 2, which is 3 joules, corresponding to 3 Newton meters. In number 40, we have that a particle P moves with constant angular speed on a curve whose polar equation is r equals 1 minus cos theta. The transverse component of its acceleration is, and we have these options. Now the transverse component of the acceleration is given by 2r dot theta dot plus r theta dot dot, and in the question they have said the particle is moving with constant angular speed omega. So each time the angular speed is said to be constant, the angular acceleration will be 0. Remember, angular speed is denoted theta dot or d theta dt, and this is omega. Since it is constant, theta dot dot, the angular acceleration would then be 0. Transverse component of the acceleration would just be 2r dot omega, since we are just left with this term having disappeared since theta dot dot is 0, and theta dot is omega. So the main task we have is to look for r dot. R dot is actually dr dt, and so we should differentiate r with respect to t, r given in the equation as 1 minus cos theta. But then when you want to differentiate r with respect to t, you are blocked in the sense that r is in terms of theta and not in terms of t. So we would have to take r dot and first differentiate it with respect to theta of 1 minus cos theta, because it's in terms of theta, and then multiply the result by d theta dt according to the chain rule. So this would give us the differential of 1 with respect to theta is 0, minus the differential of cos theta with respect to theta is negative sine theta, and then we multiply by d theta dt, which is simply theta dot, and from here we have sine theta into omega, since theta dot is omega. So overall r dot is omega sine theta. Therefore the transverse component of the acceleration, which was supposed to be 2r dot omega, would then be 2 omega into r dot, which is omega sine theta, and that gives 2 omega squared sine theta, which corresponds to option C. In the next question, we have the coefficient of restitution E of two colliding objects satisfies the inequality, and we have these options. Actually, it is option A. E always lies between 0 and 1, boundaries included. When E is 0, we have the case of perfectly inelastic collisions, and it refers to the case where the two bodies stick together after collision. When E is 1, we have perfectly elastic collisions, and they are collisions in which no energy is lost at the end. Now the value of E is simply a measure of how bouncy the colliding bodies are, usually spheres that are colliding. When E is higher, that means nearer to 1, it implies that the colliding spheres have a very high bouncing ability. In question 42, we have the value of K, for which P of x equals K into x plus 2 for 0 less than equal x less than equal 4 and 0 otherwise is a probability density function is, and we have these options. So in the case of a continuous random variable, we consider it's continuous because x values lie between 0 and 4. We have to integrate the probability density function from 0 to 4. The limits are from 0 to 4 of the function which is k into x plus 2 dx, and this should give us 1, since the sum of all the probability values that the random variable can take would always be 1. And so we have k into the integral of x is x squared over 2 plus the integral of 2 with respect to x, which is 2x, and we are taking from 0 to 4. It should be equal to 1. When you substitute the upper limit, which is 4, you have 4 squared, which is 16, divided by 2 gives 8, plus 2 times 4, which gives 8, and then minus 0, because the substitution of the lower limit gives 0. All that is equal to 1. So 16k equals 1, follows that k equals 1 all over 16, and that corresponds to option B. In number 43, we have a liquid is filling a container at the rate of 2 all over x liters per second, where x is the quantity in liters of liquid in the container after time t seconds. 10 liters are initially found in the container. How many liters will be found in the container after 75 seconds? And we have these options. So this is the case of a rate problem again, and this time a container is being filled with liquid. So there is increase in this case because the amount of liquid is increasing as time is going. So the rate would be involving an increase, so that dx all over dt equals 2 all over x, and the rate is positive since there is increase. At the end, we separate variables so that we get x dx equals 2 dt, and then we integrate both sides. On the time side, we are told that initially there are 10 liters of the liquid found in the container. So initially, that means when t equals 0, so that will give the lower bound there, the volume in the container is 10. And then at time 75, so the final time there, 75, will correspond to a value v of the volume that we are looking for. And when you integrate on the left hand side, you get x squared over 2, because the integral of x dx is x squared over 2, and we're taking limits from 10 to v that we're seeking, equals 2t. The integral of 2 with respect to t is 2t, and we're taking limits from 0 to 75. So at the end, we have v squared all over 2 minus 10 squared all over 2. When you substitute the limits, equals 2 times 75, which is 150, minus 2 times 0, which is 0. Multiplying through by 2, we have v squared minus 100 equal 2 times 150, which is 300. So v squared equals 400, and v would be the square root of 400, which is 20. So the correct option is C. In number 44, we are given that dy dx equals x minus y and y equals 1 when x equals 0. The value of y when x is 0.1 using a step length of 0.1, and the approximation yn plus 1 is approximately yn plus 2h into dy dx n is, and we have these options. So we have again that dy dx n should be equal to xn minus yn, and the initial conditions provide that y equals 1 becomes y naught and x equals 0 becomes x naught. Now the value of y when x equals 0.1, the step length h is 0.1. We would then have to be looking for x1, which is a step ahead of x naught, by the step length, which is 0.1, and that gives us 0 plus 0.1. So x1 is equal to 0.1. We are actually looking for the value of y when x is x1, which is y1. So y1 would be obtained from the approximation by substituting n equals 0. But then the approximation should first be yn plus 1 equals yn plus 2h into dy dx n, which has to be replaced by xn minus yn. So xn minus yn. When n equals 0, now we have y1 being approximated to y0 plus 2h into x0 minus y0. And we have that y1 is approximately y0, which is 1 plus 2 into 0.1, the step length, into x naught, which is 0, minus y naught, which is 1. So we have 1 plus 0.2 into negative 1, so which gives negative 0.2. So that 1 minus 0.2 gives 0.8, and that corresponds to option C. In question 45, a particle oscillates through a distance 4/5 meters on either side of its equilibrium position with a period of 4 seconds. The maximum speed of the particle in meter per second is, and we have these options. Again, it is a problem that makes use of the formula v squared equals omega squared into a squared minus x squared on the simple harmonic motion. And we have the period given, so we need to find omega, the angular speed, as 2 pi all over the period, and the period is 4 seconds, so that gives pi all over 2 rad per second. So going back to the formula, they want the maximum speed, so v max occurs at the equilibrium position where x equals 0. So v squared should be equal to omega squared into a squared, simply since x will be 0 at the equilibrium position. So v should then be omega a, which corresponds to omega being pi all over 2 into a. The particle is said to oscillate through a distance 4/5 meters on either side of the equilibrium position. So that simply implies that the amplitude is 4/5, and when you simplify, you have 2 pi all over 5, which corresponds to option. In number 46, we have that if the moment of inertia of a square lamina of side A and mass m about an axis through its center and in its plane is I, then its moment of inertia about an axis through the midpoint of 1h and perpendicular to the plane of the lamina is, and we have these options. So we have to make a sketch of the square, and it is said to be of side A. So if the axis is here, denote it I prime, and the axis through the center, we can denote that one as I, as already given in the question. Now the distance between the two axes is half of one side of the square, so it is a over 2, and I prime is actually related to I by the parallel axis theorem, which says that the moment of inertia I should be equal to the moment of inertia through the center and perpendicular to the plane plus the mass of the square lamina, which is m, into the square of the distance between the two parallel axes, which is a all over 2 all squared, and that gives I plus 1/4 ma squared, which corresponds to option C. In question 47, if the force F equals 5I minus 2J plus 3K newtons acts through the point with position vector R equals 2I plus 3J plus 4K meters, then the magnitude of its moment in Newton meters about the origin is, and we have these options. Actually, the moment of a force about the origin is related to its cross product with the position vector, so the cross product should be equal to, I'll use the column form, the position vector is 2, 3, 4 cross the force, which is 5, negative 2, 3, and the cross product should give us plus, minus, plus, corresponding to the signs that the I, J, and the K components will take. Now to get the component of I in the cross product, I strike off the top row there. When I strike off the top row, I will get the determinant of the 2 by 2 matrix left, which will give me 9 minus 8, and that gives 17. And when I strike off the middle row, I will get the determinant of the 2 by 2 matrix left by the top and the bottom rows, which will be 2 times 3, 6, minus 4 times 5, 20. So 6 minus 20 will give negative 14. And then when I strike off the bottom row and find the determinant of the 2 by 2 matrix left by the top 2 rows, I'll get 2 times negative 2, which is negative 4, minus 3 times 5, which is 15. So negative 4 minus 15 will give negative 19. And so my moment about the origin is 17I plus 14J and then minus 19K, all that Newton meters. And the magnitude of that moment about the origin should be the square root of 17 squared plus 14 squared plus negative 19 squared, which gives 29.086, corresponding to 29.1, and that gives option A as the answer. In number 48, we have a particle is moving round the polar curve r equals a sine theta with constant angular velocity omega. the transverse component of its velocity when theta equals pi over 6 is, and we have these options. So actually the formula for the transverse component of the velocity, it is found in the formula booklet, is supposed to be r theta dot, where theta dot is the angular speed and it has been given as omega. So we have r omega as the transverse component of the velocity, but then r is given in the equation as a sine theta, so we multiply it by omega so that we get a omega into sine pi on 6, because we are asked to find the value of that component when theta equals pi on 6. Sine pi on 6 is sine 30, which is half, and so the transverse component of the velocity is simply a omega over 2, and that corresponds to option A, half a omega. In question 49, a smooth sphere moving in space impinges on a similar sphere such that its velocity changes from 2I minus j minus 3k meter per second to 3I plus j minus k meter per second. The direction of the line of centers is, and we have these options. When spheres are colliding, the direction of the line of centers always corresponds to the line of the impulse, j, which is supposed to be change in momentum, should be given by m into v minus u. So m into the final velocity, which is 3, 1, negative 1, minus the initial velocity, which is 2, negative 1, negative 3, should give us that impulse, which gives 1, 2, 2. The vector 1, 2, 2 then should be the direction vector of the impulse, which corresponds to the direction of the line of centers of the spheres. So any scalar multiple, that means any vector parallel to this 1, 2, 2, would suffice to be the direction of the line of centers. And if you observe, you would see that option B is a scalar multiple of this vector, and so the correct option then should be B. In question 50, the last question, the equivalent of P of Z magnitude less than A is, and we have these options. So we should note that Z magnitude less than A actually means that Z lies between negative A and A. So we are actually dealing with P of negative A less than Z less than A in this question, and this should be equal to P of Z less than A minus P of Z less than negative A. Now, by the symmetry of the normal curve with variable Z, then this line of symmetry corresponds to the mean, which is 0. So to the left of 0, the mean, we have negative A, and to the right, same distance, we have positive A. So by symmetry of the graph, the area down there corresponds to the area up there, so that P of Z less than negative A is the same as P of Z greater than A, and P of Z greater than A further is 1 minus P of Z less than A. So we can replace P of Z less than A already gives phi of A minus bracket P of Z less than negative A, as we have just said, is the same as 1 minus P of Z less than A, and that gives 1 minus phi of A. From there, when you expand and simplify, you would have that twice phi of A minus 1 should give you the probability that P of Z magnitude is less than A, and that corresponds to option C. Thanks for watching, and for those who did not watch part 1, which consisted of questions 1 to 25, you can look at the video description below and you will see the link to that video and you watch it. You would also find other important links, especially involving playlists of the various videos involving statistics, maths mechanics, further mathematics, and much more. Also, if you are new to the channel, please consider subscribing and activating the notification bell so that anytime we upload a new video, you would get the notification and then watch.